it's my pleasure to announce this fantastic webinar, but I'm very partial because at STARTS we really live and breathe polyvagal theory. My name is Shayla Murdoch. I'm senior psychologist and team leader of neurofeedback team at STARTS. But today is not about me, it's about Joanne McIntyre, who's clinical director of Integrated Listening System Australia. We had pleasure of having Jo coming and doing training with us for Integrated Listening System. And later on, we took on a Safe and Sound protocol by Stephen Porges quite effectively. So the reason why we have this workshop is because we deeply believe in the work that Joanne does, and of course, Stephen Porges does. We even had the pleasure of having Stephen Porges come a few times to STARTS and do training. So Joanne has got many skills. She's an occupational therapist, clinical psychologist, PhD candidate for SSP trials. Have you finished, or are you still working on it with children?
Data analysis, yeah, data analysis.
Oh, fantastic. So it's just wonderful to have you. Jo, you can add more things. Of course, I probably missed a ton of things. So thank you very much. And I know you're going to enjoy this training. Thank you.
Mm-hmm. Thank you, Shara. Very sweet introduction. First of all, thank you so much for coming and spending some time with me, sharing this information with you this morning. I hope you find it really valuable. So just another little piece that I will add in terms of the connection is I did initially complete my training in Australia as an occupational therapist, and then when I was 23 actually went to the US for a work contract, and initially just for 12 months, and the 12 months extended to 23 years. I lived in Florida on the Gulf Coast, which is, you know, being really hardly hit with COVID at present. And we moved back to Australia almost 6 years ago now. And because I worked as an instructor of integrated listening systems in the US, and was definitely really passionate about the different tools that were provided. I saw it clinically in my practice, and then really wanted to help bring that knowledge here to Australia. And then we're lucky enough that Stephen Porges partnered with Integrated Listening Systems to bring his acoustic intervention essentially out of the lab to all of us to use in our practice. So we will be talking about the Safe and Sound protocol towards the end, as well as heart rate variability biofeedback, because they're both very efficient tools to help us tap into that underlying autonomic nervous system. So today I really wanted to, with this platform, be as interactive as we can. So there is a chat box. So just move your cursor around your screen, and you'll see some icons that come up, and you have a chat box that you can put questions in. So please, at any time as we go, just put questions in, and then I will periodically pause, and we can address those questions. So rather than me stopping and starting all the time, I'll try and then maybe Shayla, if you see that, oh, Joanne, you've got 10 questions before I was going to pause, maybe we could, we'll pause a little bit before then. So yeah, definitely feel free to please put your questions in at any time. And I'm just going to share my screen. Oh, that wasn't supposed to go from that one. Let me just escape. And we want to be on this one. There we go. Everyone see my screen okay?
Yes.
Okay, perfect. And you might see just, this is all about polyvagal and about connection. So I really like to keep my little tab up so I can see people's faces. I can catch anyone if they look like they're nodding off, but also just so I've got, like a face to connect with, as well, because sometimes when you're just looking at a plain screen, you just feel like you're talking to nobody. So hopefully you kind of feel that sort of sense of connection while I'm presenting this information. So we are going to be talking overview of polyvagal, and then we're going to be talking about, and I'm really going to try and talk it to the world of trauma, and as well as move on to talking about some sort of neurotechnologies that really help us tap into that underlying physiology. So I just wanted to start with Margaret Mead is known very famously for having very humanitarian quotes about who we are as humans and how we need to connect. And I think, and I sort of want to start with this because the more you kind of learn about polyvagal, you really see that it really can almost be a bit of a lifestyle, that the awareness that learning about your autonomic nervous system for self-awareness, but your eye to help detect that in others, and the whole theory about engagement really is a mindset that I think, particularly more so now with the way the world is moving, and particularly if you are in, people in the US, that we need this sort of sense of connection and kindness and social engagement. So, years ago, anthropologist Margaret Mead was asked by a student what she considered to be the first sign of civilization in a culture. The student expected Mead to talk about fish hooks or clay pots or grinding stones, but no, she said the first sign of civilization in an Asian culture was a femur thigh bone that had been broken and then healed. She explained that in the animal kingdom, often if you broke a leg, you die. You cannot run from danger. You can't, find water or hunt for food. And you're meat for prowling beasts. So no animal survives with a broken leg long enough for it to heal. A broken femur that is healed is evidence that someone has taken time to stay with the one that fell, bound up the wound, has carried the person to safety, has helped tended to the person through recovery. So helping someone else through difficulty is where civilization starts. And I think we all know from working in a helping profession that we know that the relationships that we build with our clients is a big part of the therapeutic process, that our sense of connection is very powerful. So the polyvagal theory links the evolution of the autonomic nervous system to affective experience, emotional expression, facial gestures, expression, vocal communication, and social behavior. And I'm going to unpack that as we go. Stephen Porges, these are just a couple of books that Stephen has published. There are a few others that he's co-authored, many chapters. If you definitely want to spend some additional time, learning about his work, there are numerous YouTube videos, podcasts, written work. So there's a wealth of information to really dive into to understand this work at a deeper level. So Dr. Porges is a professor of psychiatry at the University of North Carolina in Chapel Hill, and a professor emeritus at both the University of Illinois in Chicago and the University of Maryland. But why is the polyvagal theory so groundbreaking? And his theory is really being embraced in the trauma world, and the research regarding how he developed the polyvagal theory is based on over 4 decades of his research into physiological processes linked to psychological state and investigating our fight, flight, freeze, or shut down behaviors. But I think what's really powerful and why his work has been so widely embraced is it provides a biological explanation for when a nervous system goes into shutdown or disassociates. And it's really seen as an adaptive neural process under perceived life threat, which has been really powerful then to help for practitioners who really embed this model in their practice, to provide an understanding about the polyvagal theory to the clients. It provides a client with a new narrative about under that extreme life-threatening event, a new narrative of how their nervous system actually coped with that. That it wasn't like a conscious decision for them to disassociate or to give in, or that it was their nervous system that essentially took over and helped them, very adaptively survive in that life-threatening situation. So his work is being very powerful to help people sort of remove the shame that was associated with that excessive life trauma event. And because of that, his work is actually even sort of permitted into the legal field. And often individuals who have been raped or abused, or they often enter the legal world, and they're seen as like a part of the problem, that why didn't you fight back, or why did you stay and not flee? That polyvagal theory helps provide that explanation that helps remove that layer of shame and a different understanding in the legal world about really sort of what happened in that situation. So I'm just going to provide some key concepts of understanding the polyvagal. And I think as we move through today, but then you do some additional reading, you read that the resources that you should receive when you sign up for this training, and come back to these sort of main points. And these are main points that I've definitely taken out of my quite a few years now of actually really being embedded in this work. So the polyvagal theory emphasizes the parallel phylogenetic shift in both the neuroregulation of the autonomic nervous system and the evolutionary emergence of an integrated social engagement system. So the theory really is based on how we have evolved as a species, and how the nervous system has matured and evolved, and how our social system has evolved and matured at the same time. And emphasizing those phylogenetic origins of brain circuits that regulate, I'm just moving my little, oops, let me just go back, sorry. That regulate social and defensive behaviors, domains that we often see are compromised in individuals with trauma or mental health. And so I just really want you to think about that the theory really does look at these neural circuits that regulate defensive behaviors, fight, flight, freeze, but how that impacts our ability to socially engage and interact in our world. Another key concept is this kind of newer evolved understanding of our autonomic nervous system. Often the autonomic nervous system was taught as almost like this battle between your sympathetic and your parasympathetic system. However, what we're really learning now is that both systems, which I'm going to delve into a little deeper, really are very important, and they function all the time to maintain homeostasis in our nervous system, and that we need to have this flexibility in our autonomic nervous system for it to adapt to the environmental demands. But often what we see with individuals with trauma or mental health challenges is there's this flexibility in the autonomic nervous system is compromised, and that they are often stuck in a typical autonomic nervous system state, typically often sympathetic and more highly activated, or moving into a shutdown, what we call like a dorsal vagal system. Another key concept is a hierarchical organization to our autonomic nervous system. That being that we'll typically, when we perceive a little bit of threat, we'll use a more evolutionary adapted approach of trying to social engage. And it might be an eye contact, you might be the body orientating towards that person to try and sort of seek safety. And if that doesn't work, where my nervous system perceives safety, I'll move to an older evolutionary system, my fight and flight, my mobilization sympathetic system, and as a way to adapt when I perceive sort of threat. And then if my needs still fail, I still feel threatened, I move further down the evolutionary ladder, essentially, to older systems of shutdown, immobilization, essentially maintaining essential life forces. So we have this kind of hierarchy to how we kind of cope with perceived threat. Another key concept is building on our understanding of the autonomic nervous system. Typically, it was taught that we have our parasympathetic and our sympathetic, but Porges really adds the layer that we actually kind of have three circuits. And I'm not including our enteric nervous system. I'm talking primarily just about our autonomic nervous system, and our three circuits being our one sympathetic, which is our mobilizing system, and then parasympathetic, having two branches. And don't worry about feeling like you need to sort of know it all now. I'm just introducing key concepts, and we're going to dig a little deeper in later slides. So our vagus nerve has two branches, an older branch that is more related to immobilization, and then a more evolved one, which is part of our social engagement system. Continuing on with our key concepts is the linking of 5 cranial nerves involved in regulating facial expression, listening, our voice, so we can have that nice prosodic inflection. I can, based on my voice, if I'm angry or if I've got affection, or that there's sarcasm. Our voice relays a lot about my internal autonomic state. And these 5 cranial nerves regarding voice, listening, and facial expression are linked via our vagus nerve to our cardiac function. We know when someone is angry, we can tell by their voice and their facial expression, and it's directly linked to their heart, and their heart's going to be pumping. It's not going to be slow and relaxed. It's going to be pumping fast, associated to that. So we have this facial connection into our cardiac system. Neuroception, the subconscious neural system scanning people and our environment, and always appraising, is there a possible threat? So neural circuits are associated, your amygdala, the periaqueductal grey area, which is in your brainstem, and your hypothalamus. And these trigger neurobehavioral processes of approach or withdrawal. And this is all happening at that subconscious level, under our awareness. And another key concept is this idea of this neuroceptive system becoming sensitized, where a nervous system will over appraise as unsafe in actually safe environments. And I'm sure you will see this with your clients that you work with, that that their hypervigilant state is over perceiving threat when the environment is actually, based on your neuroceptive system, is actually threatened. So you have this sensitized underlying neural system, which is over appraising possible threats in their environment. And when this happens, it makes it difficult for the nervous system to actually cue into or perceive cues of safety from the environment. Another really key important component of vagal of polyvagal theory is that physiological state limits the range of behaviors and psychological experiences. So it's almost like thinking of the iceberg. It's the layer underneath the water. So our underlying autonomic nervous system, our physiology, creates the lens of how we see and interact in the world, creates the state for our emotions, how we engage or disengage with the world. Cues of safety help individuals co-regulate towards health, growth, and restoration. And we know from the science of attachment, and we know from the interpersonal neurobiology, that relationships are very powerful of sending cues of safety to a nervous system. So we can tap into this, what we call it, the restorative vagus, where we can have this health, growth, and restoration. And it's through our ability to co-regulate that self-regulation emerges in the autonomic nervous system. So polyvagal theory is about learning about our own autonomic nervous system. We really can't help others until we really are attuned to our own autonomic nervous system state. Remembering neuroception, that we're always picking up on the subtleties of body language, tone of voice, facial expression. And so we're always sending messages about our own autonomic nervous system to other autonomic nervous systems in our environment. So the best way that we can be the best therapists, the best parents, is really learning about our own autonomic nervous state, our own triggers, our own glimmers, and how do we trigger more of those glimmers so I can be in the most regulated state, which then will help those around me be in the most regulated state too. So again, we can really sort of apply this theory to our day-to-day life. So not just in working with clients for therapy, but really with our families and with our spouses and friends. And another nice gift that this theory gives to us is a language, around how we actually start to have this conversation about learning about our autonomic nervous system, and one that we can use with our clients and our kids. Where do you think you are on the ladder, and which I'll get to a little bit later. I always like to include this slide. So this is, unfortunately, I've added another little bit at the bottom. So this is a slide of neurodevelopment by Schellberger. And I first learned about this model, this pyramid, many years ago when I was a younger OT, because occupational therapists often learn about our sensory systems and how our sensory systems, which are down here at the bottom of the ladder, really impact, particularly from a neurodevelopmental perspective, how that impacts a nervous system's ability for gross motor and sensory motor integration, for attention, for learning, to regulate behaviors. But what we've really been learning, and what the gifts of polyvagal give us, is really understanding that as the base, even beyond these sensory systems, and we talked about arousal back then, but we didn't really connect arousal system to our autonomic nervous system. But our polyvagal helps us bring this piece of our central nervous system to understanding it, like the bottom, the iceberg, underneath the water. We have this hidden component that really lays the base. And what researchers is telling us even more so now is even, beforehand, that our genetic predisposition, and the experience and what we get carried through the generations in our genetic code impacts our central nervous system. So the research is showing that if our grandparents or great-grandparents lived in or had experiences of excessive abuse and hardship, that their DNA was changed with that accumulated stress over time, which then was passed down through the generations, where, for instance, like if my parents were and great-grandparents had incredible hardship, and I may be born with an autonomic nervous system that's more sensitized for possible threats, or sensitized towards more of a quicker activated stress response, so more vigilant. So coming into the world, I come into the world with a central nervous system that's more sensitized. So with that, my base, my sensory systems become sensitized. I come in possibly with my tactile system being a little bit more on the alert. Well, touch doesn't feel as calming and pleasant, where it actually feels a little bit noxious and unpleasant. My vestibular system, which is my balance system, becomes more sensitized, where moving a lot in space actually feels uncomfortable. Proprioceptive system is like the receptors in my joints to let me know where my body is in space. That can be compromised too. But in particular, we see our visual system that become more vigilant, looking out for threats in the environment, and an auditory system. So you think if an infant comes into the world that has this sensory system that's that little bit more vigilant, and a little bit of an autonomic nervous system that's that little bit more sensitized to a stress response, that whole attachment process then of those little sort of serve and returns with their caregiver becomes compromised in some sort of way, because typically babies coos and smiles, these sort of innate responses are biologically wired into us to help our caregivers want to raise us and protect us. But if those infants' cues they're more sensitized, then that impacts that attachment process. Those serve and returns could become compromised. So those cues of safety in those early years can become compromised. So I'm just trying to sort of give you that sort of idea that how these things can happen from early on. And with a lot of clients that you probably work with, where their parents have been in war-torn environments, lost loved ones, lived in that constant threat all the time. Even though they may move to a country like Australia, their children are born, but yet they still carry a DNA predisposition for a nervous system that's sensitized towards possible threats in their environment. And then if we work up the pyramid, that can impact balance, coordination, knowing when my body is in space, my sensory system just feeling just more sensitive, my hearing's more sensitive, my ability to regulate my emotions are impacted, my ability to focus and attend and listen when I start going to school becomes impacted, my ability to have social connection with peers become impacted. And so it impacts the whole pyramid. And then for adults over time, if I've got this accumulated, because sympathetic system is being activated all these years, and the research is showing that when you have a sympathetic system that is constantly being on guard every single day, our restoration processes of our vagus nerve becomes compromised, and there's a higher predisposition as adults to cardiac disease, diabetes, to mental health conditions, to cancers. And I'll add this little, when I get into the science, we'll add it. But if we can kind of think about this throughout the lifespan, and I like to try and add little bits throughout as we go, the more you hear it, then the more it sort of all kind of makes connection. So definitely remember, if I'm going through, you've got questions, pop them in the chat box at any time. So a nice overview of the polyvagal theory is this slide that you can find on Google. So this is the autonomic nervous system according to Porges. So we have our environment outside, but we have our internal and in our interoceptive processing or awareness as well. And then our nervous system, or our neuroceptive system, which is constantly appraising threat or not. And if my nervous system, my neuroceptive system perceives safety, then I'm in an optimal arousal state. I'm going to use the ventral vagal branch of my parasympathetic system is engaged, connecting to those 5 cranial nerves, facial expression, eye contact, for voice inflection. So I'm calm and I can focus and I can engage I have a positive outlook. I see possibilities in my environment. If my nervous system, neuroceptive system perceives danger, then my sympathetic system becomes activated. This is my mobilization system, moving towards hyperarousal. If you use, the work of the window of tolerance, where my window of tolerance is going to start to sort of narrow a little bit because I'm perceiving some sort of threat. So as I narrow, I become a little bit more rigid. And then based on my nervous system, I may move into a fight-flight response. Now, if my neuroceptive system perceives life threat, this is when I move into using my dorsal vagal system, the hyperarousal. My heart rate will decrease. Your physiology moves to preserving essential life forces. It's immobilization, freeze, disassociation, collapse, fainting. They're biological adaptive processes to help survive under perceived life threat. So this is a nice visual, like if you are going to talk to a client to help them sort of be aware of what's actually happening in their nervous system. This is a nice introductory and simple way to help them visualize. And then you can unpack a little bit, what do you see in your environment when you feel like you're, possibly in a ventral vagal state where you feel happy and content and engaged and see possibilities. So you can kind of use that to unpack a little bit about what this means for that particular client. This is just another way to visualize exactly what I talked about, that we have our social engagement system, which is our ventral vagal, our more evolved part of our autonomic nervous system, that where our facial expression, our ears for listening. I want to keep bringing up the ears because we're going to be talking about an acoustic intervention, the Safe and Sound protocol, because our ears for listening, whether we're tuning into frequencies of human voice for engagement or whether my ear is tuning into predator-related sounds, is really important. So in my calm, ventral state, I have calm behavioral states, and I'm inhibiting the sympathetic nervous system. And then my mobilization, again, this is all, so under perceived threat, my sympathetic system mobilizes me to either fight or flight, or it can be active freeze, because we see people freeze and they're in anger. There's a lot of energy inside. So it's not always, like a fight or a flight where there actually is active mobilization, that we can freeze with that sympathetic energy. And then moving into immobilization, where that dorsal vagus is perceived life threat, collapsing, submission, death feigning. And we see all this in the animal kingdom. Our autonomic nervous system is shared with throughout the animal kingdom. But we are the only species that trigger our autonomic nervous system, particularly our sympathetic system, based on what we're thinking. It is designed to help us fight and flee from a threat in our environment, but we're triggering it when we're worrying, when we've got schedules to meet, when we're running late, we're caught in traffic, we're triggering this sympathetic system. So we really need to learn, how do we stay in a more ventral vagal, calm physiological state. And this is just a cute slide to really emphasize that we experience autonomic states in our body, and this helps us cue into neuroception. Really look at people's bodies. What is their body language telling us? Because you can read what you think might be actually happening in their autonomic nervous system. So looking at their posture, you know, how they're holding their shoulder girdle, their facial expression, if they're, you know, putting their head towards you to nod. That we know when somebody's depressed. We don't need for them to tell us. We can read it in their facial expression, but entirely in their body language as well. So our sympathetic system ready to mobilize our, you know, ventral vagal. I'm cool, I'm chill, I'm relaxed, I feel good. And then this is dorsal vagal when I perceive life threat is when I'm moving to that shutdown. Because I do, and I will unpack this again, but I just really want to emphasize that I'm talking about if we perceive life threat, the different responses that our autonomic nervous system, our sympathetic system moves to action, or our dorsal vagal will move to immobilization. But remember, these systems are functioning all the time to maintain homeostasis. So we need some sympathetic activity just so I can get up and get going for the day. And then, you know, like when we play is sympathetic. I've got some mobilization in my system, but I have my ventral vagal on guard at the same time, so I can be happy and engaged, socially engaged, and mobilized at the same time. So it's not an or none with these, that they're working in a balanced way depending on what is adaptively happening at the time. So dorsal vagal is that immobilization part of the branch of our vagus nerve, but when we don't perceive life threat, its function is restorative. So it helps us relax. It's what's more engaged when we're doing meditation, when we're doing breath work, if we're doing yoga. That our dorsal vagal is engaged and helping with restorative processes. So I know when I was very first learning polyvagal, I kind of was thinking of all this as all or none, but both systems are working all the time dynamically together to help us function optimally based on the environmental demands. Everyone doing okay? Give me a little thumbs up. Yep, perfect. So let's unpack a little bit more of this neuroception, you know, our internal assessment mechanism, you know, evaluating safe or unsafe at that subconscious level. So this system is processing our inner world and our outer world, what's happening in our environment, and our between world. So we're this, you know, and it makes sense that we have this evolutionary evolved system that is processing all the time for a possible threat. And it's so sophisticated. And if we didn't have this, you know, we may not have evolved as well as what we have. But it's when this system can maybe not work as efficiently for us is where people can have some challenges. So as I mentioned earlier, the main structures that are involved in this neuroceptive system is your amygdala, which is in your kind of, I'm going to say your limbic area. Some people in the neuroscience are moving away from using your limbic area, but it's in your temporal area. And it's like your threat detecting, but it's your emotional center of your brain. And it connects with your hypothalamus and brainstem for a particular area that if you read some of Bessel van der Kolk's work, he talks about, you know, periaqueductal gray area, that this is really seen in the brainstem as a big part of processing fear and fear responses. And your brainstem is where those nuclei are that control your physiology for heart rate and respiratory system and respiration. So we have this strong connection into your threat detecting system, into your physiology, making your heart pump and your respirations increase to get blood to your extremities. So under threat, I'm ready to fight or flee if need be. Or if I perceive life threat, my physiology will move to life preservation processes. So this area is so this circuit kind of acts as central intelligence, scanning every perception or situation, evaluating is this a threat, and setting off those, particularly under threat, of withdrawal related or defensive related responses. So some additional work, if you want to investigate more about the defensive systems in our nervous system, another layer that I found really interesting is our peripersonal neurons. And this is the work by Dr. Michael Graziano, and he has an amazing book called The Space Between Us. And it just adds another layer into understanding these neural systems in our body that are essentially designed to help us detect a possible threat so we can survive. So we have these neurons are actually in our motor strip that it's almost they process almost like the bubble space around our body, but particularly around the front part of our body, because I think this is where our heart and our lungs are. And it is detecting visual and auditory or objects that approach our body, and at a very primitive level, when they stimulate these particular neurons, we have motor repertoires like swiping behaviors or ducking behaviors that will help us, swipe away like an object that's approaching our body. So I think it's just really interesting that we have all these neural circuits that are wired to protect us. And if you work with children, you'll often, this was a lot of my work, and sometimes the parents or the teachers would complain that little Johnny can't stand in line, because if somebody just happens to kind of walk a little closer to them into their space, they might lash out or they'll hit them, and so little Johnny was often being reprimanded, but little Johnny's life was incredibly not safe at home. So his neural circuits were wired to be vigilant, to be in a protective mode. So continuing on this idea of our brain wired to detect that threat. So based on the science of neuroplasticity, that neuroplasticity and how our brains basically evolve is how we interact in our environment, is how our brain grows and how it builds all its neuroconnections. And a great, a sad evidence about it, but just very strong evidence, is the early studies of the children in the orphanages in Romania, who there was, huge amount of children in a room in individual cribs and like one caregiver, and essentially they went around giving them a bottle of nutrients and taking care of some basic hygiene needs. But so these kids had no attachment, interaction, no stimulation, and when people started going in and seeing what was going on, and when they really researched these children, their brains were so underdeveloped, where they were smaller, there was less white matter neural connections, and then there was global delays in speech and language and motor skills and sensory skills, and their ability to interact, socially interact in reciprocal ways with people were, tremendously compromised. And, their genetic predisposition was with possibility, but their interaction with the environment was so compromised that the brain didn't have the opportunity to develop. So a brain that grows in an environment of neglect and abuse and life trauma is going to get wired in a more defensive, protective manner, where that amygdala becomes enlarged. It has more receptors for like cortisol, for threat. Your HPA axis, which is your hypothalamus pituitary and adrenal gland is just stress response, it becomes sensitized, where it doesn't take much of a stressor in the environment to trigger this access and set off a cascade of other sort of neurochemical stress-related responses. Part of the brain being wired to detect threat is your misreading of facial emotions become compromised. A nervous system often perceives neutral faces as actually defensive, as they misinterpret it as angry. And the misreading of voices, neutral voices, can be often misinterpreted as angry or attacking as well. So just keeping this in mind when you're working with these clients with such complex backgrounds of how they're actually seeing the world, and you can be completely different to how you think they might be. And many of you are probably already so aware of this anyway. So this just helps to connect it to the theory and what's happening in the brain and the body. So when we feel safe and socially engaged, our nervous system is essentially doing two things. So this is when we're in that nice ventral vagal state. When we're in that, with that parasympathetic system is helping to inhibit that over fear-based activation. So it inhibits this vigilance, this underlying defensive neural wiring in our nervous systems. And even though I've been talking about a picture of a nervous system that's sensitized based on its genetic predisposition or its early life experience, innately, even all of us who have a neurotypical upbringing, we have a built-in, defensive bias in our nervous systems, and it's part of this old neural survival wiring system to be a little bit more on that edge for possible threat. And I don't know if you even sort of notice, sometimes an email might come in and you read it and you kind of feel like, I wonder what they think they mean by that. You just find yourself just a little bit like, and then if you sort of like, well, let me just sort of restart and let me read this email with a definite positive reframing, it reads entirely different. So you need to sort of realize you sort of got to catch yourself that we have this little wiring to kind of be a little bit more defensive, even in a neurotypical nervous system. But more so, this becomes heightened when you've had early life trauma and stress. And again, because we're going to be talking about acoustic intervention, just want to highlight the ear changes when we're in a more sympathetic, threatened state, where it's almost like the tuning dial on a radio, which none of us really use a radio too much anymore, but when we want to try to tune into stations, now we can just press buttons. But the older radios, you actually had a tuning dial that helped you kind of tune into different radio stations, and you kind of had to get rid of the static, and then you sort of got into the actual station, nice, clear and crisp of what you wanted to tune into. But our ear makes these changes, and it's all biologically wired. So if I'm perceiving threat, the tuning in my ear sort of shifts, where I'm not tuning into human voice as much, and my ear is listening out for what other possible threats might be in the environment. And they typically tend to be lower frequencies or high frequencies, or like alarm sounding sounds. So these are like, particularly kids who are in school, and they can hear if somebody's walking in the hallway down outside, or they hear the lawnmower, down, off in the schoolyard doing garden work, or they can hear if the teacher's phone buzzes, that their ear is listening for other possible threat-related sounds. So you can imagine then, it's not a hearing loss, it's a perception and tuning in how much they're actually missing of what the teacher is saying in class. And the same happens for adults in relationships that who are having, sort of couples issues, that if the ear is always listening out for possible threat, then they're not hearing their partner as clearly, and they're misreading their emotional inflections. And so that just helps, impacts that whole sort of circle of communication and connection. So I'm just going to keep unraveling the important part of the ear in this process. So essentially, hopefully you're getting through all this, that safety is therapy, that we need to help individuals who have experienced trauma or accumulated stress, detect more features of safety in their environment. Everyone doing okay? So now we're going to get into a little bit more of our autonomic nervous system, helping us understand that a little bit more. So as I said earlier, our autonomic nervous system primary job is homeostasis, and that we need to have the flexibility for it to work together so we can adapt to the different environmental demands. But we know that many of the clients that we work with typically tend to be stuck in that sympathetic activated state. So our two main components of our autonomic nervous system is our sympathetic and parasympathetic. Remember, our parasympathetic is broken into our two divisions. So looking at our diagram, we'll start with our sympathetic system first. So our sympathetic system is here on the right, and you can see it comes from our body. It comes from if you just want to put your hands, sometimes if you just do this, it actually gives it like a connection more in your brain, because some people, I forget where the sympathetic system and the parasympathetic comes from. But if you put your hands like on your ribs and sort of bring your hands around towards your back and feel your spine, and then sort of run it down towards the lumbar part of your spine, this is where your sympathetic system comes from. So, and it innervates your viscera, your lungs, your heart. It increases your heart rate. Really important thing to know is that it inhibits digestive activity. So many of your clients, particularly if you work with adults or even children often complain of, they have belly pains, belly aches and pains. They miss school because their tummy hurts. Adults who end up developing IBS, irritable bowel syndrome, other digestive issues, that if they're in a sympathetic state all the time, being triggered not only just by big traumas, but a daily accumulated of stresses, is impacting your ability for your digestive system to work primarily. There's so much research coming out about our gut-brain axis, that our gut is our main component of our immune system, that when your gut health is compromised, your brain health is compromised. Your gut is, I know people who work in mental health often just don't think, what's digestion got to do with anything? But our inner biology is a huge piece of the puzzle of our mood and our mental health. So we don't need to be experts in it, but we need to know that if there's problems, that we need to try and connect with other professionals in our environment who can help them take care of inner health issues. And often it is more complementary medicine. There are doctors that specialize. I keep on forgetting. Like in the US, they're called functional medicine doctors. I've just forgotten what they're called here, but they take more of this full body systems approach to trying to understand the different challenges that individuals are happening with. So think also, if my gut is compromised, my digestion's compromised, my ability to pull good nutrition out of food becomes compromised. The nutrition is what enables my cells and my brain cells to work optimally, which can become compromised. And over time, that can then lay the foundations for possibly cancers or autoimmune challenges, that because this sympathetic system is really impacting the restorative functions of what happened with our parasympathetic system. But our gut is a huge piece of the puzzle. So trying to connect with good dietitians who specialize in gut health, naturopaths and nutritionists who really understand the whole gut-brain connection and how to help that. In complementary to the mental health work you do, you would just see leaps and bounds in changes in helping your clients, reach their optimal health function. So our sympathetic system inhibits gut health. It stimulates that glucose release in the liver. So if it's always been stimulated all the time, you can see the relation then to diabetes. Inhibit saliva. That's why when people get stressed, people don't like speaking in public. They get that really dry mouth, and the mouth gets clammy and hard to sort of find your words. So our sympathetic system, under threat, is impacting all those functions. But remember, in health, the sympathetic system enables me to have some energy to mobilize, to move. It helps my heart go pump a bit faster, so I can play, so I can go for runs, so I can be more active. It's when it feels my neuroceptive system perceives threat is when I'm going to move into more defensive fight flight related or freeze in anger related responses. So don't think of it always as it's bad and it's negative. Our parasympathetic system. So again, if you put your hands behind your neck here, okay, that's close to where your brain, and move it up a little. That's where your brainstem area is, and your parasympathetic system, which is primarily your vagus nerve, comes from your brainstem. So then it makes sense that this nerve will connect with these other cranial nerves that are related to my facial expression, which I'll show you in a later slide. So your vagus nerve is your 10th cranial nerve. It's known as your wandering nerve because you have this single nerve that has huge branches that connects to all the similar viscera than what your sympathetic system does. But it has the opposite effect where it'll slow it down. It slows your heart rate. It has nice input for rhythmical breathing. It stimulates digestive activity. It stimulates your immune system. It's involved in all cellular restoration processes. So it is the state to be in to help optimize your rest and rejuvenation and digestion, that it enables our body to kind of reboot itself to maintain optimal health. So we want to create as many opportunities as we can throughout the day where we can have episodes where our parasympathetic system kind of dominates what's happening, where we can got this health happening. And it's in this not only biological health, but it's where our brain is inhibiting the sympathetic over defensiveness, and I can be more clear-minded, I can be more calm, I can start to integrate some of those other maybe cognitive strategies that I've been working with my therapist on. But when I'm in a sympathetic state, my brain's busy and I can't think clearly, so I can't actually integrate all these wonderful breathing and meditation and cognitive reframing sort of strategies that I'm being taught in therapy practice. So we need to target, how do we target our physiology so then my brain and my body is actually in a biological state where I can start to pick up on cues of safety. My brain can actually start to think more clearly, and I can take in all the wonderful strategies that my therapists are telling me. So here is a beautiful diagram of our vagus nerve. And we're going to have two, because it's going to come out from the base of my skull, but it comes down both sides of my body. And you can see it has all these amazing branches to all those internal viscera and my heart, which I showed earlier. So this system we're learning so much more about. Often it was taught more of its motor output, the impact that it had, like it helped with digestion. But actually the research is telling us there is more information. All these connections and networks are actually collecting information from our body and relaying it to our brain, to letting our brain know what is actually happening in our body. And then the brain will send information out. So it's an integrated feedback system, involved in regulating visceral state and our affect. And we know when, like, your tummy hurts, you automatically look, you can see my face, even I don't have it all the time. My face went into an expression of pain and discomfort. My shoulders elevated and my voice got a little tighter. I felt tightness in my chest and I felt like that little bit of stress. So based on my visceral, even though I was perceiving it, a visceral response, I have a body response and I have a sympathetic and a thinking response. So we have this total connected system. So our vagus system is bidirectional, sending sensory and motor signals, that there's more information coming from our body to our brain, and that when we have increased vagal tone, so sometimes if you read some of the literature around this work, you'll hear vagal break, vagal tone. So I want to try and use it interchangeably. I'll give you the definition, so you get, you don't feel like you're throwing when you read about this. So your vagal tone, just like when you've got good tone in your arms, it means that muscle that vagal system is well engaged, that it's not flaccid and loose and not functional, that we have good tone in that system for it to work. So when we have a good vagal tone, where we're in that calm state, it promotes those biobehavioral states of being calm, regulated, my cortex ready optimally for thinking, and we have those rest and digestive and rejuvenation processes. It's inhibiting that amygdala's over defensive vigilant states. It's inhibiting the HPA stress response. It's improving a thing called heart rate variability, which I'll be explaining to the end. But heart rate variability is an essential measure of autonomic state, but stress in our nervous system. So it's a really important thing for us all to know about. It promotes immune function, and vagal tone, through its connections in our heart, through this vagus nerve connections up into the thalamus, which is like a relay center to the brain. If my heart rhythms through my vagus input are calm and relaxed, it connects into my thalamus to help my cortical rhythms be calm and relaxed. So when you see people calm and they've got slow breathing, and if you do measure their heart rate, and it slows down, that why they start to think clearly is because you have this neural connection via vagus nerve, thalamus, cortex, where that cortical activity starts to slow and fire in a more rhythmical way. So our doing breath work is a powerful way to help tap into this system, and I'll talk more about this as we go on, which through neural connections taps into cortical activity to help your brain think more clearly too. I'm a big believer. I just think if you learn about the body and you learn the different neural connections, then you know what you're tapping into when you're doing certain techniques. So it helps bring that evidence to practice. So just expanding about Porges' findings about the two branches of the vagus nerve and how that evolved over time. From the brainstem area, where you have these nuclei, you have your ventral vagus, which is more that the evolved part of the vagus branch, which is in this picture you can see it innervates its subdiaphragmatic organs, so primarily your heart and your lungs. And this is actually myelinated. I'm just putting this out there so you can, when you read, you'll sort of say, oh yeah, Joanne mentioned that. So myelinated means that it helps to facilitate the neural message along the axon. The myelin sheath helps that neural message to actually travel along the axon much quicker, more efficiently. So again, it makes sense. We have a more evolved system. And this is part of our social engagement system, but then it's part of what we call like the ventral brake, the vagal brake. And I'm going to explain this more when we talk about heart rate variability, but just file it away. Vagal brake is the input from that vagus nerve going down to your heart to help slow your heart rate down. So then I can be calm and regulated. I can regulate my breath, my facial expression. I can think clearly. So then the other part of the vagus nerves, when we have our two branches, which goes below the diaphragm, to below the diaphragm. So this is unmyelinated. So those messages are going to travel that bit slower. And this is part of our immobilization, shut down part of the system. So I'm just going to expand a little bit on our sympathetic system where it's overactivated. Again, when we perceive threat, whether we're actually seeing it in our environment or remembering what I said, that we're the only species that triggers this system based on what we're thinking. And there is so much research regarding the science of stress in our bodies and the impacts that it has, and the connection to cardiac disease, to, I've unraveled a little bit of the gastrointestinal issues. They've actually shown research with accumulation of adipose tissue around the abdomen. So when the nervous system or the body is under a perceived threat, they, because we went through periods of, famine and fasting, when there was no food and it created a stressor in our nervous system, the body felt like it needed to accumulate calories in case for those periods where we might be having famine again. So we have these old wiring systems where we're under stress, where our body will actually start to accumulate adipose tissue around the abdomen. The overactivation of the HPA axis, that stress response I talked about the amygdala, talked about the immune and fertility issues. And I don't know if you've ever heard stories of women who have been on the IVF program for many, many years, and they've finally are successful and have a baby. And next thing, they're at home, they're happy, and a couple of months later, next thing you know, they're pregnant. It's not uncommon. And the reason often is because the nervous system and the mind get so caught up in, I so want a child, and the stress, and particularly IVF is stressful on the body and the process you have to go through, then part of biology is when your body is in a stress mode, you don't need to be reproducing. You need to have every energy resources available in case you need to defend some sort of predator. So fertility issues, fertility and reproduction biologically gets put on hold. And then shortening of the telomeres. The research is showing that when we have this accumulated stress over time, that the telomeres are like little shoelaces at the end of our DNA, and they shorten over our lifespan. However, they're seeing that when people who have had a lot of accumulated stress, that their telomeres are actually shortening, so they're having premature aging. Interesting, the research who are really looking at this, the relationship with telomeres and stress, have noticed that in particular, individuals, when they put them in different programs, but ones where people have felt like support groups. People have been put into support groups and they have that felt sense of connection. They've actually seen that their telomeres are improving, that their lifespan improving. So again, leading to the importance of how we're wired to socially connect and the importance of relationships, that biologically the relationships we have, the impact that it has on us promotes ventral vagal states, rest and rejuvenation in our nervous systems, and it helps us to thrive. I find the work around stress just absolutely fascinating, and one of my favourite persons who's rather entertaining as well is Professor Robert Sapolsky. I'm not sure if anyone's come across his work. He's got a popular book. It's been out for quite some time now, Why Zebras Don't Get Ulcers. I've actually got an Audible, but you can just buy it. It's a great book. It's entertaining. It has this sort of nice sort of satire approach and wealth of information, and you just pull that into your understanding of the nervous systems that you work with, currently, in terms of particularly working with individuals with trauma. Another great resource that he did is it's on YouTube, and it's a documentary. Pretty sure it's called like Stress, the Deadly Killer. I'd love it if we had time. I would have us go and watch excerpts of it. It's not a dry documentary. It actually is so entertaining and it's so interesting. So if you can take some time out, I think it's 40, 50 minutes, but if you can take some time out just to watch that, you'll be blown away. It's really, really good. So please try and add that to your to-do list. And he's got lots of different YouTube presentations, but those two I think are great. And since we're talking about the impact of stress on our biology over time, has anyone come across the ACEs study? Give me the thumbs up, or if you have, or this is okay. I've got Kath, and I think I've got a few people who've said this might be new. So I am not going to go into great depths about this study. I just want to introduce it. When I first come across it, I was like, wow, this needs to be part of every curriculum, from teachers to psychologists to mental health counsellors, occupational therapists and physios. Everyone who works with people should be familiar with of what this study involves. So this was, there's lots of papers been written on this study. This was a research conducted by Kaiser Permanente from the Centers for Control and Prevention. It's got a really interesting starting point of how it even sort of came to be. The main physician behind it was actually working with individuals who had weight issues with obesity, and who were putting them on different plans. And he was noticing that some people would lose the weight and would progress and be okay, but then there would be some women who would come back and they who'd lost all this huge amounts of weight and then would turn up for a follow-up visit, and within a short period of time basically ballooned back, and them some, to before they even started working with him. So it made him really sort of question what else might actually be happening with this. And so when he investigated a little bit further, he found that many of these women had abuse backgrounds, and that had been attacked, and that the weight was a way to essentially protect themselves. So really sort of built up this understanding of obviously the connection between mental health and body weight. But then when he investigated more, he saw that many individuals with these sort of challenges had significant early lifehood experiences. So this Kaiser Permanente study involved over 17,000 participants, and they conducted this interview where they were identifying, early adverse childhood experiences. And So they're called like the ACE, called like an ACE score. So the experiences include things like emotional, physical, or sexual abuse, neglect, having a mentally ill or addicted parent, losing a parent to death or divorce, living in a house with domestic violence, or having an incarcerated parent. So each of these would accumulate, like a score of 1. So the higher your ACE score, so the more of those events that you had in your life, they found the higher correlation with things like, if you look here on the scale, with like disrupted neurodevelopment, social, emotional, and cognitive impairment, with adaptive health and risk, adoption of health and risk behaviours, that there was increased, I kind of said social problems and diseases, and then early disease. So there was a high code. The more higher your ACE score, the shorter your lifespan, and the higher your percentage and incidence of actually having a disease like diabetes, cardiac disorder, adoption of addictive related behaviours. And it was all strongly correlated to those early life experiences, which I know many of you know that many of the clients that you work with, particularly if you work with adults, have early life challenges that have contributed to why they're coming to see you. But to know that there's an impact on that biology in terms of disease and disease processes. So again, why we want to try and identify children or individuals at an early stage, so we can start to create changes before they move in this trajectory. And other people have taken this data and they've looked at depression, and they've looked at children with learning challenges. So the data has been processed and correlated with a lot of other difficulties. So it's a really interesting study. So essentially, stress has a huge biological impact on us, not only just mental health, but on physical well-being too.
Sorry, George, just a quick question. Are you thinking of having a break anytime, or what's your program? Because we didn't talk
in the beginning. Let me just see where I'm at. That we'll do a 20-minute break. So if we can just go to like
10:30.
Yes. So that gives me like another 10 minutes. Yep. And then we'll do a 20-minute break. Now, thanks for jumping in. Sometimes it's hard trying to get caught in it all. And
it's beautiful. Thank you.
I just forget to sort of stop. So in terms of, what I said, like in the beginning, how you can kind of take this work into your daily life, but also your work with your clients. The work of Deb Dana has done a lovely job of taking polyvagal theory and putting it into workable exercises and a language that you can start to embed with your clients. And one of the tools that she uses, and I'm just introducing today, we don't have time to go into great deals, but one of the tools that she uses is a polyvagal ladder. And it's like, it gives a nice visual. And you can see here's like a picture of the ladder on the side, where we've got safe and social at the top of the ladder, sympathetic, which is mobilized, or fight and flight in the middle, and then dorsal vagal and immobilized. And she kind of uses this as a tool to help unpack where, like, when somebody sort of, where are you right now sitting on your ladder? And then unpack even more. She uses like a roadmap analogy, because maps often help us learn, directions that we need to kind of take, that's going to help take us towards more optimal health, but helps us sort of start then to work through a process of looking at, okay, when I do feel safe and social, what's in my environment, or what do I feel in my body that makes me feel this way? And sort of exploring those sensations and thoughts and environmental cues. And then the same when somebody is sympathetic or mobilized, fight and flight, and then dorsal, and what does that sort of look like? And again, it's trying to build that self-awareness. You can use this with parents, so then they can learn their own maps and then help them start to identify what they might see in their children. The more aware of autonomic states, looking at body language, facial expression, and voice, that gives the individual the opportunity then to take that moment to check in, where are they at, and pause and think, what do I need to do to help me stay in a more ventral vagal state, so then my cortex is optimally, so I have a more adaptive response to the situation, rather than, if you check and you're like, oh, I'm moving, I can feel my heart going a bit faster, I can feel my shoulders elevating, oh, I can hear my voice is getting a bit tighter, my face is getting a bit, I'm moving towards a stressed state. Checking in and being aware of that, a parent may then like, you know what, I don't need to react right now to little Johnny, sort of running around in the living room, that I can just get myself into, I'll go do some breathing, I'll go and see what I need to do, some strategies I might do to just get more grounded. So when I come back, I'm in a more adaptive way to help redirect Johnny's screaming or running around behavior. So then it's a more harmonious outcome. And the power of doing this kind of work takes away the blame of bad behavior, bad parenting, that you're looking at biologically what's happening and identifying what tend to be triggers for you, and giving a sense of control. So families or adults or individuals have really liked, this gives me this language and this understanding and looking at my body and what seems to be triggers, gives me then a sense of control and autonomy about, okay, these are the things I need to work on to help tap in and regulate my physiology, so then I know that my brain can actually have more adaptive sort of strategies. So let's get through social, and then we so our social engagement system. So again, this is all part of polyvagal. Remember I said way in the beginning, one of our key concepts is our social engagement system that connects 5 cranial nerves. And those cranial nerves, this is just a beautiful picture to show how connected these cranial nerves in. So we have our 5 is trigeminal, that has innervation to your face, but you have little connections from trigeminal into your ear for listening muscles. Our facial muscle for facial expression, glossopharyngeal, which is part of for our voice, for our inflection, vagus, which comes down into our heart, and our spinal accessory is part of where our head's nodding. That people look, I'm listening, I'm orientated to you to listen, and our body expects this kind of feedback. That Porges, if you read some of his work, sometimes he talks about this biological violation, that we're sort of wired to expect kind of interactions like a facial expression, eye contact, and head nodding, and that sometimes, particularly when we use like gadgets, let's say we're at a cafe with a friend and we're having a really nice conversation, and then her phone rings or she gets a text, and then she stops looking at you and she looks at her phone. Inside, our neuroreceptive system actually processes that as a biological disruption, because the messages she just said is like, well, I'm not as important now. It's more important to see what just come up on my phone. And that disengagement, looking away, sends these messages. So your nervous system sort of reacts in a little bit of like, it's like a distancing. So it's good for us to be aware that when we're really with people, be with them. And this is just another way of configuring this information, that those cranial nerves, they're involved with muscles of mastication. So again, there's a group of psychologists in the US who work with eating disorders, and they've actually moved their intervention model to work from a polyvagal perspective. Instead of focusing on behavioral strategies or intake, how much intake people are consuming, they're moving to a polyvagal perspective because they've looked at this neural connection into glossopharyngeal for food, for sensory, for connection to my heart, for regulation, and for that engagement part. And they've moved to creating cues of safety. How do I regulate the nervous system? How do I to use a polyvagal informed approach to working with eating disorders, and they're getting some really nice results. Often we have feedback from practitioners who work particularly with children on the spectrum. We have a lot of eating and sensory challenges around eating. And when I talk about, we use the Safe and Sound protocol, which is like a portal into our autonomic nervous system to help with regulation, and have seen, now that I have a nervous system that's more calm and regulated, children's exploration of food and openness to try different foods has really increased. So if you work with people with eating disorders, think a little bit differently about embedding polyvagal and a different approach, and possibly does that open up another way to actually work with them, of a nervous system orientated one way. So our social engagement system, that integrated neural system, has a lot to do with that prosodic inflection of voice, which gives, you can tell somebody's emotional state of affection or sarcasm or love. Gaze, again, is cues of connection, facial expression, mood and affect, our posture, all letting you know what state my physiology is in based on my posture, facial expression, and tone of voice. And that we see observable deficits in our social engagement system over different psychiatric, neurodevelopmental, and behavioral disorders. And Porges really tries to talk about not always looking at a diagnosis, really looking at the nervous system, what's happening in the autonomic nervous system, but looking at that social engagement system and what might actually be being particularly impacted with that client that you're working with. And again, reiterating what I said earlier, that in trauma, often the misreading of facial expression and vocalizations become compromised because we're in that defensive, sympathetic underlying lens. And importantly, that ear in a defensive state is over perceiving threatening in the acoustic information in their environment too. So our face to heart connection. Remember that picture from the beginning with the little boy with all those neural connections that connects down to the heart. So we have this as a portal for us to tap into. That just looking at these images, I'm sure automatically you kind of like, you look at them and it makes you want to smile, and makes you feel good inside. So we're tapping into a couple of systems. We have our mirror neurons in our brain that tend to mirror what we see, but there's actually been some, and we know we have this neural connection between facial expression and our heart. I mean, we can't smile and our heart be pumping away in a stressed mode when we're smiling because we're happy. But there's been some really interesting studies. You might have heard about the pen study, where they've done studies with individuals where they've had individuals hold a pen like this or hold it with pursed lips. And some of the earlier studies had these individuals holding the pens in that way and was showing them images, and they were asking them, what did they kind of see in the images? And people who tended to have the grin, it looks like a grin, tended to see more sort of positive aspects within the images, where the people with the almost pursed lips were actually seeing more negative aspects in those images. There's numerous studies, and I know we have time to go into many of them, but recently Flinders University replicated this study and actually did some brain scans, and they saw that the amygdala in like the more happy emotions were actually being activated when people had the grin. And they actually recommended at the end of this study the possibility of people doing therapy where they actually have people hold the pen in a grin-like image, in grin-like posture, because they see, when they looked at the physiology, they saw this feedback loop from the face being made into the musculature and those neural systems being made into a smile, has a feedback loop into your physiology to have that effect of actually being a more positive orientated. So we are going to finish with, everyone, you can choose either to have your pen, and I'll do it because people might feel silly if I don't. I want you to have your pen, and we're going to do it for 60. I want you just to think about how you feel now. I've kind of obviously smiled and made you feel a little bit more positive, but just think about where you're at now, just for 30 seconds. We're going to sit, and I just want you to see what you sort of notice. Okay, so you ready? And also just look at the faces at the same time. Okay, and take a break. So now I just want you to unmute yourself because we're about to have a break, but just unmute yourself. And so just I'll call on if everyone noticed, or if there was a particular face that they felt like they connected more, or if they noticed anything. So let me see. Shayla, did you notice anything?
Oh yeah, definitely. I noticed sort of almost, I call it relief inside the chest, just kind of just relief. And I must say, the dog cracks me up. So every time I look at the dog and the baby with those bottom teeth, I just want to laugh. So, and I'm like, and so it's just joyous. It just makes you whole body. And I feel that my posture is a bit more open now after this.
Mm-hmm.
Thank you.
Yeah. Anyone else want to jump in?
I could see that in Shayla. I was actually not looking at the pictures. I was looking at the people, and I could see that in Shayla, actually. Of all the people, that's the one that kind of stood out for me. So good to hear that that's what I was actually picking up on, that state.
Thanks, darling.
Anyone else want to add?
Can I just add, when I put the pen, I felt, firstly, before I'm looking to the photos, little bit tension around my jaw. But when I just looked, it's attract me the baby and the man beside the baby. So I realized a little bit relaxed.
Thank you for sharing, Marcel. Yeah, I noticed I just took a innate sort of breath when I sort of was just looking at it, and just like, so my body, my parasympathetic system was like, just, okay. And so just sometimes it's the simple things that we often overlook. And sometimes if we really understand neurally how we're wired, that we can come up with simple ways to help shift our clients' autonomic nervous system, or even ourselves. When you're sort of having, I know I've been trying, because since I've read the research and stuff, I know it's like, the whole COVID, my family's split up right now. I've got half my family, my husband's down in Melbourne and I'm up on the Gold Coast. So we're trying to do some stuff through Zoom, but some days you get up and you just feel a little lonely. And so I'm like, okay, I'm going to just try and do some smile work. And I look at and I've been pulling up some pictures of happy faces, and you notice that there's a shift pretty quickly, that we can tap into this system pretty quickly. And so then that makes me think about, some of the depressed clients that we work with, that it's very hard for them to feel an emotion, although they still might look at these sort of images and not necessarily have the overflow to their face. So them actually doing a pen exercise where their muscles are kind of forced a little bit into that position can help their face start to assume, the musculature assume that sort of smile response, which hopefully then will overflow. But the visual and the motor together is an important thing. And then also remembering that, another piece of the puzzle I want to add is, if you're interested in learning more about facial expression beyond what polyvagal talks about, there's some great work by Dr. Paul Ekman into like facial, micro-facial expressions. He actually has an online training platform that you can do that helps you start to learn to pick up on these little micro expressions. And he's done training programs with the US intelligence office and stuff, so they can really help pick up if people are being truthful or not, or trying to pick up their mood. So he's done fascinating work, and part of his work too was seeing the connection between facial emotions and our physiology. So really
Can I comment on that, Joanne?
Yes.
I just wanted to add something to that based on something I've observed. My father has Alzheimer's, and we provide some respite care for my sister, who's his primary carer. And I noticed that his response to the sounds of children and their facial expressions completely changes his mood. Whereas as adults, when we're in the room and talking, he can't make sense of what's going on.
Yeah.
And you can see him scanning, trying to make sense. But as soon as one of the children, shrieks in joy or jumps or whatever, his face just lights up. And there's this contagion between his emotional state and their emotional state. Whereas generally he doesn't know what's going on, and he's kind of often in a kind of disconnected state. And it just made me think of that as we went through this activity and exercise, how much kind of his system is activated by these obviously quite deep and primitive responses to sounds and facial expressions and noises that children make, which are nonsensible, really. There's shrieks and great big smiles and jumping in water and all that kind of thing. But you see his face respond positively with smiles and interest, and he comes out of this state of disconnection.
Wow, that's powerful.
Right.
Yeah. Thank you for sharing that. That was very lovely. Let me go ahead and get started. So we did start a little bit talking about play, and I'm talking about this from a polyvagal perspective, and how our autonomic nervous system links into our social engagement system. And so, Porter's really talks about it as a neural exercise, because play is a blend of social engagement, and so when our nervous system is mobilized and it's activated in that absence of danger. So when we're playing, we have our sympathetic nervous system engaged, but we're using the cues of safety, of facial expression, of eye contact, of looking at our friends while we're playing, to help us be mobilized but safe at the same time. So it helps in our nervous system develop that flexibility of having both systems engaged at the same time. And often what we see with some nervous systems is that they start to mobilize, that they start to actually get, that you hear those, particularly if I'm thinking about kids, but it happens with adults too. It's like all or nothing. They're on and then they're off. They have no sort of graded in between. And it's often because they don't have this flexibility or this dual engagement of their autonomic nervous system. So once their sympathetic starts, then it's like it just takes over, and they quickly escalate into a mobilized fight or flight sort of response. And part of this is this system that I'm going to elaborate on is your vagal brakes. Remember I said the vagus nerve comes down and goes into your heart. So your heart naturally pumps. You've got your pacemaker, which naturally has your heart pumping all the time, about 90 to 100 beats a minute. So it has its own intrinsic beat rhythm. But it's the vagus nerve that innervates that sinoatrial node, that pacemaker, which it puts a brake on it to slow it down. So when we're calm, we have more of this vagal brake, slowing my heart down. And then when I need to move and mobilize, the vagal brake starts to come off. So then my heart rate speeds up. So it pumps more blood, I can move, I can have action. But it's this balance between the vagal brake coming on, helping me slow down so I can play and engage, or it comes off where it just pumps and then I have a sympathetic sort of overflow. So play helps me to learn, and my nervous system helps me to learn to mobilize, but with safety. So it really is developmentally a very important nervous system exercise to develop those vagal brake and understanding of the sympathetic system not going out of control. And it helps exercise our neuroceptive systems of looking at our friends as we're playing for facial expression, tone of voice, body language, safe space, like pushing too hard, not too pushing too hard. So we learn a lot about that sort of serve and return, about interplay with each other. So Rachel, I think if you can create in that school the awareness of the importance of play, in teaching nervous systems how to regulate. So then when they're in class and they're starting to feel a little bit stressed because maybe they don't get what the teacher's saying or the lesson's a little hard, instead of them escalating out of control because their stress response takes over, they've learned how to kind of manage that a little bit and have a bit more of an adaptive response. So play is important. So going on this idea of where our world is taking us, and remember way in the beginning, I showed you the picture of like us as cavemen, that biologically we are wired to connect. We know that's why people come to therapy. The relationship matters. It's what helps us thrive. But it's the relationships that help us learn how to regulate our autonomic nervous system. It's how we build in the regulation, we build in that resilience, we build in where that window of tolerance becomes expanded, but it all happens through our connections. But society is moving where we have our devices and we don't learn how to manage our nervous systems. We turn to a device to relax, to unwind, to distract ourselves. But we're doing this to our kids, that we're giving them devices which they are learning at a young age to regulate with an object. They're not learning to regulate with somebody else, which helps their nervous system build in this resilience. That window of tolerance is expanding. So long term, they're not going to learn those skills, not cognitive skills. Their nervous system aren't going to learn those skills of how do I self-regulate, because as soon as I feel a little bit stressed, where's my device? I need a device and I need to block out the world. But there's going to be a lot of situations in life where you can't do that. You know, you've got a conflict with a spouse, you've got a conflict with a co-worker, with your boss, if you haven't learned these regulation skills and you can't turn to your device when you're in that sort of situation, then you're not going to cope so well and you're not going to move successfully through life. So again, thinking of the biology, that it's this face-to-face attunement, it's that connection. So just imagine that previous picture that showed the neural connection with that facial and trigeminal nerve connecting through that vagus nerve into the heart, that you know, creates those emotions of, I know I feel safe, I feel heard, I feel connected, and I'm helping my physiology through this connection build the resilience internally. So we did break a little earlier, so I was going to try and get through those slides first. So we're a little bit behind. So now I've kind of given an overview of polyvagal and hopefully made some additional connections for you all. So now we're going to sort of start to really talk about these neurotechnologies that we can use as portals into our autonomic nervous system, because I know you have those clients that come in that either shut down, that you can't actually make any progress, or in such a vigilant, sympathetic state that they really can't have any momentum with a lot of the therapy strategies that you're offering. And these complex nervous systems, sometimes we need to go in a different way. You know, I know Shayla, they use neurofeedback as a tool of helping the cortex, the cortical activity slow down as a portal into the nervous system. And they do use the Safe and Sound protocol. And it's not that one is what works for all. We sort of need to know these tools and see which ones are possibly going to be the best fit for the client. So our ear, in my journey of learning, is really a powerful way to access the autonomic nervous system, but for us to realize the connection. You know, often people think about our ear and it's like hearing, you know, for audiology, or they think about speech and language and articulation components, but our auditory world connects so much into our our mood and our mental health, our ability to connect with others in our environment. As that's part of the building the relationship. Is, can I not only hear that person, do I hear all the inflections of emotion that is carried on the spoken word? And we know many people with compromised nervous systems miss all this rich emotional content, or they misread it, or it's too much for our nervous systems. So our sound is a nutrient for the brain. When they've done studies like of deprivation studies where people have absolutely no acoustic input whatsoever, people start to go like mentally ill. That our brain needs sound as a nourishment, but then sound is very individual too. That, you know, we have sounds that you know, that can stress us, that can soothe us, and definitely connect us. And certain sounds for certain people are definitely more calming, and for others they can be triggering. So we have sensory branches from the vagus nerve that come to your ear, and there is quite an expanding world of vagal stimulation therapies. They've actually been doing, there's vagal implants where they actually surgically implant a device to help stimulate the vagus nerve. Because if you remember back in the early, when I went and showed the autonomic nervous system, that we know that vagus nerve is so restorative and helping to create the calming in the nervous system as well as the health. So, you know, science and the medical world are realizing that we need to help sort of engage this system more to help optimize health. There's the implanted ones, and then there's a transcutaneous vagal nerve stimulation, because you actually have sensory branches from the vagus nerve that come to the tragus, which is like this little part here on the ear. So there's like a little sensor you can put on the ear to help tap into the sensory branches of that. And then we're going to be talking about Porges' polyvagal theory, which is not polyvagal, so the Safe and Sound protocol, which is an acoustic vagal nerve intervention, because it does help tap into this vagal system. But let me unpack a little bit more about our auditory system and help make that connection into mental health. So in this picture here, we can see we have our ear that captures sound in the environment, and sound is just like displaced air molecules. And our ear captures all the sounds. So people talking, cars and outside, the air conditioning, birds outside. So all this acoustic information is what gets captured and relayed into the inner ear for processing. So here is your tympanic membrane or your eardrum. And then you have this ossicle chain, which are the smallest bones in the body. And these vibrate as that acoustic information hits the eardrum. And then it sends this information into, and here's our vestibular and cochlear apparatus. The vestibular system is our sense of balance. It really lets us know where our head and our body is in space. And it's connected to all our writing reactions and all our muscles to help us kind of stay upright and react to sounds. And then our cochlea is our processing of that acoustic information. So sound comes in, vibrates, the eardrum, those little bones vibrate, and they send information into the cochlea, and it starts to work out, based on the vibrations, what all those different sounds are in the environment, so I can make sense of it. So we have important functions in this middle ear component. They're not shown in the picture, but we have little ear muscles, 2 little ear muscles that stabilize our eardrum and this ossicle chain. Because what happens when this vibrates and these bones, the way the physics are designed, they amplify sound. So the middle ear muscles help dampen, they put tension on that tympanic membrane and those bones. So when sound hits it, it dampens it so that sound isn't amplified. So when we're in a vigilant state, those little middle ear muscles start to go offline. They're not as active because the ear wants to try and listen for low predator-related sounds. Think about when we're out in the savannas and hundreds of years ago, and we needed to survive. So I needed to be able to listen out for the growls of lions, so those low frequency predator related sounds, so then I could have a motor response to flee and survive. And then, or a loud, alarming sort of sound, screech sound. So my ear needs to be able to listen out. So in order to do that, I needed my eardrum to not be tense. I needed to be able to listen out. But that amplifies sound. So often what we see with individuals with hypervigilance and trauma, those little middle ear muscles are not engaged and sound.
Hello, how are you?
Sorry, did I miss someone? Does somebody have a question, or they just accidentally unmuted themselves? Okay. Yeah, so a lot of people with trauma is because these middle ear muscles aren't engaged, sounds tend to be amplified. So they'll share with you that, I have a lot of auditory sensitivities. I don't like going into like restaurants or, hearing children with those loud screeches, or, I don't like if there's too many people talking at one time, or I don't like going into like public bathrooms and the hand dryers are so loud that their things in their head are amplified, and it's real because these muscles aren't doing their job. So those middle ear muscles essentially put tension on that tympanic membrane to help stabilize it. They act as a muffler to protect the ear, almost like, when there's a bright light and how your pupils constrict. So the muscles engage too when there's a loud sound to help engage. So think again, if they're not working efficiently, sounds amplified. But a big important job is that they act like a fine tuner. So when they stabilize this tympanic membrane, so it's not vibrating with all that acoustic information, they're able to pull out human frequencies for engagement, and in particular, all the rich fine-tuning information of the emotional content of spoken word. The other job is to suppress, so whatever time we talk, they engage, so our own voice is not amplified in our head, and so they enable us to hear and talk at the same time. So they really play an important function, And you could see that if they're not engaged because you're vigilant and sound is being amplified, then that creates almost that catch-22. Because sound is so loud, it triggers the sympathetic system, high vigilance state, even more so. So this is just another representation just to show. So here we have our tympanic membrane in the yellow, those middle ear bones. And here we have our stapedius muscle, and here's the tensor tympani, which is stabilizing those middle ear bones. And the cochlea, which is almost like a snail shell. And so their job is to stabilize that, so then we can pull relevant human speech and language from background noise. So Porges actually did studies on different species and saw that the relationship of the length of these middle ear muscles and the tension they put on the tympanic membrane enabled each of those specific species to be able to pull out. They specialized the ear to tune into their species specific frequency for engagement. So we're designed to tune in to each other. So this is another nice way to represent the information. So in this top picture, here in the squiggly line is all that acoustic information coming in. Here is our eardrum. Here is an inactive stapedius muscle. And because all that sound is being amplified, low frequency information, background noise, tends to travel in like big waves, and rich human frequencies of all the emotional content tends to be smaller waves. So what happens when this is inactive, the low frequency waves kind of override my ear's ability to pick out that rich information, almost like, you know, when you think about an ocean where you have the big waves coming, but in front of them you've got all those little waves. So it's not like those little waves don't exist, but the big wave kind of comes in and crashes over them. So it impacts your ability to actually see those small waves. So it's not hearing loss, it's a perception that's compromised. And in the bottom diagram, again, acoustic information coming in, hitting the ear. I've got an active ear muscle that's engaged, dampening all that background noise. Now I can pull out human specific frequencies. I can actually start to tune into the emotional content that's on that spoken word, enabling me to really engage, start to pick up those cues of safety through the connection into vagus nerve, slow my heart rate down so I can, you know, feel safer and pick up on more cues of safety.
Jo, there is quite a good question about audiologists that don't pick up on sort of issues related to auditory processing. And do you have any comments about that?
Mm-hmm. So with an audiologist, if you could get a central auditory processing evaluation, that helps with helping us learn a little bit more about what's actually happening with the ear. But particularly with adults coming, if they're in your world dealing with trauma, if people have a history of trauma, okay, and they're sharing with you that they've got auditory sensitivities, that they're having difficulty, you know, they misread people's spoken word, and part of all that, you know, they often perceive somebody's being angry with them when they're not. They have social engagement challenges of really connecting and maintaining relationships with people, and there's always been this over time. Then it's another window to let you know, and you know they've got this sympathetic stress system happening. You're going to pretty much assume that those ears are not doing what they're doing. As we go through, I mean, I'm just introducing to you this idea of the ear as being a part of the puzzle, and part of the puzzle that we can impact with an acoustic intervention. We have, and there'll be some resources to come and learn more about the Safe and Sound protocol. From completing this training, you'll get a $50 discount to do the Safe and Sound protocol practitioner training, which is all online, and Dr. Porges gives a lot of the presentations. So please bear with me. This is just kind of introducing this idea and this concept to you. So in the training that we offer, you can learn about an assessment. It's called the scan, which helps you. There's a practitioner you can have your clients complete, which gives you a bigger window into letting you know that those middle ear muscles are not doing their job.
So, Joe, that's different to central auditory assessment,
Yeah.
scan. Yeah.
Yeah.
And yeah, so I've done the scan myself, and I knew always I had auditory processing issues because I have cocktail deafness and I never liked noisy places. So I know the scan, I had I went to test my hearing was perfect. There was nothing wrong with any sort of central auditory processing problems, but the scan had shown that particularly one ear had more problems than the other.
Yeah, so audiology evaluation will really just detect hearing. It'll give the ability to detect sound frequencies, but it's how we actually pull out and make sense of those, where if an audiologist does central auditory processing assessment, but then as a clinician, we can use the scan to help determine, is that ear able to pull out from background noise, which helps you, because our ear, if you're really having difficulty, if you've got that auditory hypersensitivity, but if you're having difficulty picking out the emotional content, you always feel disconnected. You're misreading people's emotional content, member neuroception. So then your nervous system starts to get activated, thinking this person's angry with you when they're not. So your nervous system is being in a more activated sympathetic state. So our ear really does play a big piece of the puzzle in helping.
And I did find helpful to, if you can find audiologists that understands this a bit more, and what tests they use. Because I know when I did a course in Melbourne about auditory processing. It was like 5-day course. I don't know. We had audiologists talk, and it was one person in whole of Melbourne that kind of understood this. So
yeah,
good luck finding somebody in Sydney if you're in Sydney. I don't know anyone in Sydney.
Right. But even without an audiologist, the fact that people are sharing with you the behavioural component, that is real. That's their world. So then, you need to sort of take that into consideration. And since we're talking about audiologists, we've actually had a few audiologists who use the Safe and Sound protocol, or we've had some psychologists. I know there's one actually in Sydney who worked with an older client who completed the Safe and Sound protocol. The client went back to their audiologist, and their hearing perception of sound frequencies had improved, and they actually had a pre and post audiological evaluation. Because then if those middle ear muscles are working, then your perception of sound can improve. But again, it's finding an audiologist that's a little bit more behaviourally orientated could be useful. So I just wanted to put this slide in as a little bit of a summary of what we're sort of talking about. And if you're ever talking with a client trying to make this connection of, particularly if you decide to do the Safe and Sound protocol intervention, making this connection about why I'm doing an acoustic intervention, why I've got mental health challenges, or I've got a lot of anxiety, or I tend to go to depression, or I have huge history of trauma. So in this slide, we're using like a traffic light analogy. So if my nervous system perceives safety, then my nervous system, my autonomic nervous system feels relaxed. I've got more of my parasympathetic engaged, and I can feel calm and socially engaged, and I'm able to rest and digest. And my ears, the tuning in my ears, my muscles are engaged and my ears are able to tune in and really hear all what you're telling me and the meaning and the emotion behind what you're telling me. When my nervous system moves into like a yellow state, like a bit of a warning state, then my sympathetic system comes on board, and I tend to move towards mobilization to protect, for possible danger, and which may lead to fight and flight. And the tuning in my ear shifts to listen out for other things that may be threatening in my environment. And I'm missing then often the emotional content of the spoken word. And then if my nervous system perceives life threat, I'm moving towards immobilization to freeze, and my ears tuning is the offline. I'm not really even like, it sounds like wah, wah, wah. I'm not really hearing what you're able to sort of share with me. And so when I move back to yellow state, this is why parents talking to their child having a meltdown, it's not going in. They've actually got, if you go back to basic biology and survival, if they moved back and used prosodic inflection, it's okay, very sing-songy, very slow, then I need to send cues of safety to a nervous system that's going towards that fight and flight shutdown. I'm in a temper tantrum. So not using words, not using anything that has any cognitive, but it's using this inflection. Think about motherese. We use that. All humans globally use motherese with a newborn infant, to that sing-songy ups and downs, that as a species, that vocal play is what sends cues to another nervous system that you're safe, I'm safe to be with, and we can be calm together, we can connect. We use this without even thinking about it. When we speak to our dogs, it's like, oh, come here, and you use this slow ups and downs, sing-songy voice. When we want them, we need a nervous system to be calm. So keep vocal play and prosodic inflection map it away as a tool that you can tap into to help a nervous system feel calm. But it's the ups and downs, inflection, and slow that our nervous system, evolutionary wise, will tree into. So I expanded a little bit more on this slide than what I intended, but I just wanted to put this one up as a summary, but just trying to make that connection with the ear. So the Safe and Sound protocol is an acoustic neural exercise for those middle ear muscles. So according to Porges, hypothetically, interventions that improve the neural regulation of the social engagement system should enhance spontaneous social behaviour, physiological state, and affect regulation. They reduce stereotypical behaviours and improve language skills. So all aspects of that social engagement system that we talked about a little earlier. So the acoustic intervention is vocal music that's been electronically modified to emphasize the frequency band within human voice. It's modulated over the 5 hours to emphasize the prosodic features. So just think about what I was talking about with all that rise and fall, which sends cues of safety to our nervous system. It's just how we're wired. Those aspects, have been overemphasized within the protocol. And the filtration occurs progressively over 5 hours. It was traditionally, the original research was 1 hour a day for 5 consecutive days, but we've learned a lot over the last 3 and a bit years since it's been released, in terms of often we need to sort of slow it down and match the input to what the nervous system. And the reason why you kind of progress forward is that Porges actually developed a device to measure those middle ear muscles and how they were responding to that acoustic information. So because they're quick twitch fibers, you don't want to over fatigue them and then they just go offline. You want to give them, so it's like an exercise. You want to exercise them, make sure they rest, exercise them, so you can start to have them engage to do their job, their functional job on their own. So the acoustic intervention is 5 hours total. There's research to show improvement with emotional regulation, social engagement, decreasing auditory hypersensitivities, helping with auditory processing to pull voice from background noise, helping to decrease anxiety, trauma-related challenges, and inattention. Because you think about, if I've got stress and I've got auditory where it's hard to really focus on what I need to focus, then it's hard for me to really pay attention. Or if my ear's always listening out for other threatening sounds, how can I possibly focus efficiently to learn in class or be productive at work? And really the findings is that the tool helps to facilitate enhanced therapeutic process. So there is both a version for an adult and a child. They're both filtered exactly the same. They've just the music choices, just a little bit more suitable to each age group. There's really criteria around how the acoustic intervention is implemented. And it really is about a passive intervention. It's about creating that safe space where the nervous system can be as calm as can be, so they can actually, you can maximize taking in that acoustic information. So environment considerations are things like, making sure that there's no phones on, there's as minimal other background distracting noise as possible. And the intervention is typically delivered through headphones. Sometimes if you've got a really challenged nervous system, like children with a lot of sensitivities, or even some adults with autoimmune challenges, and we go into all this in the training, sometimes we've actually delivered it through speakers as a way to help just change, shift the nervous system in preparation to eventually doing it with the headphones. So I am just going to, we're just in the process of releasing the digital version of the SSP. How are we doing for time, Shayla? I keep
well, depends how much more material you've got, Joe.
I think we're supposed to have about another 20 minutes. Is that
20
right?
minutes. Yeah, it finishes at midday.
Yeah. So I've got another video, but we might just, it's like an overview, nice video about it. So, but I'll wait to at the end, and I'll make sure that you've got a link to the video if we don't get to watch it through it. It's just a nice overview about what the polyvagal theory is, and then what the protocol is. But since the protocol's been released, 3.5 years ago, because of people's a lot of the clinicians who really embrace polyvagal theory, there's a lot of mental health practitioners that use the protocol in their therapy, and many give us the feedback that if they use this as a starting point, it creates the shift in the nervous system where they get more momentum with all the other tools that they were having as part of their plan to help their clients reach their maximal potential. We have a lot of practitioners who do EMDR training, for instance, who use the protocol, because often in EMDR training you have that phased approach. And before they can even do any processing, they need to do a lot of resourcing with the nervous system so they can actually cope with any of that sort of trauma processing work. And so using the protocol in that beginning phase has enabled the nervous system to be resourced and grounded, where then they can actually do a lot more of their active work and move through the healing process much quicker. So it's not considered like a be-all and end-all, that it's all part of the therapeutic process, and that it just enhances the other things that you've been trained to do. So it doesn't replace, it doesn't take away, it just really supports those other things that you've been taught already. And is that what you've found, Shayla, through using
Yes, we found a lot of changes with children, but actually quite dramatic changes with adults. And we see quite really severely traumatized people. So with adults, we saw people who nothing really worked. After the SSP, they slept and they haven't slept for 10 years properly. And suddenly wanting to reunite with their children again, who they had issues with. So really profound changes.
Excellent, great. And that's often the feedback that we get from practitioners. So I will have links at the end to, if you want to find out more about it. My email's at the end, and if you have any questions afterwards, I'm happy to answer any emails. But it is a tool that is like a portal in that helps create those opportunities to help your client's nervous system regulate. So the next tool I want to talk about is heart rate variability. It's another evidence-based intervention. There is so much research investigating heart rate variability, as well as using it as a tool to tap into for assessment, as well as a biofeedback tool. It really is considered the gold standard in measuring autonomic nervous system regulation in the body, that kind of vagal tone. What's interesting is that Porges was actually one of the first pioneers that developed some of the measures around measuring heart rate variability, in particular sinus RSA, which is respiratory sinus arrhythmia. So there's a couple of variety of tools available that measure heart rate variability. Thought Technology HeartMath or the IOM2. I know Shayla talks about using HeartMath. I used HeartMath previously, but now we're sort of involved in with the IOM2. So I'm going to talk during this presentation a little bit more about what the IOM2 is. It's nice to know what options are available and using this kind of tool with your clients. But I'm primarily going to help you have an understanding about heart rate variability and why it is good to know about it and how you can use it in your practice. So the IOM2 is interactive biofeedback and a meditation program. And it really is, when we keep on thinking about the vagus nerve, that, I see it as it's a tool to help us tap in to that restorative vagus system, which helps build that resilience and that health. So what is heart rate variability? So it's the measurement of the time intervals between each heartbeat. There are some people, when they think, oh, my heartbeat's about 60 beats a minute, so they think it beats like on the second every minute, every second. So exactly on the second each time, but we actually have variation in the time between each interval. So you can see in the picture like 8.45, 7.45, that we have this variation in time between each beat. So that's heart rate variability, but it's really linked into the autonomic nervous system input on the heart and our breath cycle. So let me just add those layers. Remember earlier I said that we have our pacemaker in our heart, which is our sinoatrial node, which has an intrinsic, it'll just beat on its own about 90 to 100 beats a minute. But it's the input from our vagus nerve, that's that vagal brake, onto that SA node, that sinoatrial node, that helps slow the heart rate down. And then our sympathetic activity input to the heart will speed it up even more so, because we know when we work out or we're running really fast, our heart's beating more than 90 beats a minute. It's like 130, 140 beats a minute. So the sympathetic system helps to make that happen. So it's the input between both parasympathetic and sympathetic, which is having an impact in the time intervals in between the beat. But then this is the big important component, is the impact of our breath on our heart rate. So let me I'm going to exaggerate. I think you can see me in the picture. So I'm going to exaggerate it slightly, so you can sort of see. So when I breathe, so imagine I've still got my vagal brake coming in on my heart that sort of slows it down. Okay, so my heart rate sits about 54 beats a minute. Okay, so when I breathe in, that vagal brake lessens a little bit and my heart will speed up. Okay, I'm exaggerating, but it speeds up. Then when I breathe out, vagal brake comes back on and my heart slows down. Breathe in, comes off, not totally off, but it comes back on. And then I breathe out, vagal brake back on. Okay, so we have this input into our vagus nerve on our heart by our breath cycle. And we know through breath work that there's a lot of science out there that talks about breath work to helping us calm down. There's breathing in yoga, there's a lot of different practices that tap into breath. But I'm a big person about science, so I want to understand the science, because then when I understand the science, then that makes me like, okay, I'm really going to take this breath stuff really pretty seriously and start to actually do work with it myself. So let me go back a little bit. So as I breathe, so I'm just going to review this. So as I breathe in, I speed up. So when I speed up, the time interval between my heart lessens. Okay. Then when I breathe out, the time interval increases. So that helps with this variation in time. What happens when people are in a sympathetic state, the heart's beating fast all the time. They're not having this speed up, slow down, speed up, slow down that goes with their breathing cycle. And with them not having that variation, then they lack the variation in the time interval. So this time interval, which is linked to our respiratory cycle, is incredibly important. And as I said, so it's an indicative measure of vagal tone. So how healthy our vagal system, which is almost like an indirect measure of how much sympathetic activity I have in my nervous system. So too much trauma is, I'm going to, like mental health or anything, I'm going to have less variation in that time interval. My heart rate's going to beat faster. And typically my breathing is up in my chest. I'm not getting air down into my lower lungs. There's so much research. I'm pulling out one in particular because many people work with trauma. They've actually done studies, mainly in the US, when they're looking at veterans, that individuals going into service or going into the military who had poor heart rate variability measures, when they come back from deployment or anything, their prevalence of post-traumatic stress was higher. So versus ones that had better heart rate variability measures before going to a military zone, that there were less prevalence of post-traumatic stress. So there is a relationship then. So I have more stress in my nervous system going into a stressful situation. So therefore I have less resilience to bounce back from that stress. So again, it's measuring when I've got a sympathetic state, I don't cope well with extra stress in my nervous system. There's research that looking at longevity studies, what do we need to do to live long, healthy lives? So there's huge research going into that. And the number one measure they're using is heart rate variability. So they're looking at, is it lifestyle, social relationships, exercise, diet. They're looking at all these variables, but they're using heart rate variability as a measure to indicate health in the nervous system for the impact of those different variables on health. So Stephen Porges did some initial early research looking at heart rate variability in premature infants, that premature infants with poor heart rate variability had poor longevity. There's lots of research in psychology around looking at decision making and heart rate variability. There's studies where people who addictions or food diets, and they've been wearing sensors that's reading their heart rate, and then they're using software to analyze the interbeat time interval, and researchers in the next room can tell if somebody's going to give in and have that cookie if they're on a diet and they're not supposed to, based on seeing decreased heart rate variability measures. So seeing a little bit more stress in the nervous system shows that they're more prevalent to actually give in to whatever their addictions that are doing. Cardiology use heart rate variability as a measure of longevity when they've done heart transplants. They're looking for how healthy that autonomic cardiac system is. So it's a huge measure. So they've looked at studies with breast cancer survivors doing heart rate variability via feedback, biofeedback, ADHD studies, complex trauma, pain using heart rate variability biofeedback for pain management, pregnant women's musicians, athletes. Some athletes use heart rate variability biofeedback to improve performance, because if I can improve the time interval, I'm tapping into that vagal system where I can be calm and focused and regulated at an optimal level. So in teaching heart rate variability, from a polyvagal perspective, this is a way that I like to add to it, is adding, not only teaching somebody about their breath work to help tap into the vagus nerve, but adding that heart to face connection, like the exercise we did earlier with the pen, that often different biofeedback practices talk about having this sort of sense of gratitude while they're doing breath work. But I think when we layer in some of the signs of polyvagal, and when we have somebody actually have a smile on their face at the same time, then I know I'm tapping in double to not only through breath work, but through that facial social engagement system to help strengthen that vagus input on the heart, so I can help with improving heart rate variability scores. So I'm kind of aware of the time, so I'm going through this part just a little bit quicker. So I'm not reading all the information on the slides, but you will get the slide deck. So biofeedback from a polyvagal perspective, we want to layer in that part of the whole face to heart connection. And often as you learn about biofeedback and heart rate variability training, the optimal range for optimal health, where this restorative vagus is online, is around 5.5 to 6 breaths a minute. And you'll see in the next slide that when you wear a little sensor, so the IM2, you have a sensor on the ear, and the heart rate and HeartMath also has a sensor on the ear, and you get like this graph reading that comes out. But optimally, when we breathe at that cycle, we get this sort of nice sort of ocean wave, sinusoidal up and down wave. And the goal in learning breath work is to do this effortless breathing, that it's calm and relaxed. And based on the science of neuroplasticity, the more that you can have somebody, and even yourself, practice this using a biofeedback mechanism, that we're helping to retrain our autonomic nervous system to be in more of that parasympathetic state. And sometimes using something like a technology is what really connects doing this kind of work with particular clients. Some clients find it really hard just to do like mindfulness or to do breath work or to try and do relaxation work. But often when you give them something like a technology like the IM2 or the HeartMath, where they wear a little sensor on their ear and it connects to a device that connects to either their phone, the program on their phone, or on the laptop, it gives them a little bit more structure. And then they get like a biofeedback reading, and that's what makes the connection for them to sort of do this work. So the one thing I like about the IM2, the reading is actually a little bit more simple, and it's very, very engaging and interactive for clients. So I find clients tend to, you practice it in your sessions, And then I like to set them up so they do the work at home. So they get that homework, the more practice I'm getting shifts in that vagal system. And because the graphics are very engaging, they like doing it. So they like doing the work at home. So the compliance and the staying with the program is great over time. So this is just a feedback screen. With the IM2, you get like a resonance score, which is measuring that heart rate variability and giving you a resonance score, which is kind of indicative of how much stress you might have in your system. So in this particular screen, so I've pre-work, I've done some breath work, I've showed them the face-to-heart connection. So in this work, they've got the screen and they can see their heart rate and their resonance score, which is at 77%, which is pretty good. But being in a calm state, this hot air balloon is like flying over different sort of beautiful landscapes. So as soon as, let's say, their mind started to wander or they started being stressed, then their resonance score would go down to like the 40s, and then the balloon would stop going over these landscapes. So you kind of get this visual feedback, which taps into the stress measurements in your system via that sensor. This platform also gives you like a dashboard, so you can see how many sessions somebody's done. Here's their total amount of how many hours they've engaged with the program, the average resonance score, so over time, their average sort of stress in their nervous system. And then this is just like a graphical representation. So the biofeedback, in this program, there's quite a few different, they call like journeys, experiences. Another one is like ruins. You go into a set of like old Roman ruins and there's things that you need to repair, like a pool that's lost all its tiles. So they're kind of interactive, but not too much. And again, it's your physiology and being calm, and you see your resonance score to see, and you see the repairs start to happen, which gives you that sort of positive feedback. So in this screen, you can see you can go to a screen which only just has a simple graphic representation. The HeartMath gives you a little bit more data. If that's an avenue that you would like to learn more about, then the HeartMath gives you that. Eventually, the IM2 is going to be updated with Porges' algorithm, so there will be more data available. But right now, it's a more simplistic resonance score. And so you can see here in this picture, it's a little bit more jagged. You've got a slight sinusoidal wave that's going with the breath work, and that's sort of what would be going for is this nice up and down. So this is just talking about the different platforms, but another nice component of the IM2 is the meditation. So we have the interactive biofeedback, which is kind of almost like that game-like experience, but then the meditation component. Meditation is growing in its research, the fMRI studies, EEG, to show the benefits of doing meditation. Again, that's tapping into that restorative vagal component of your nervous system, that being mindfulness helps you be more present in that moment, to help you take that pause in how you're going to respond. The nice thing that I find with the IM2, I know I've had a few adult people who've been like, I've been, regular meditators, I'm really good at it, and yet they started on the platform, and actually their resonance score, because you still get a resonance score as you go through the meditation, wasn't as low as what they thought it would be, so it really helped them see that, I wasn't actually getting into, my physiology wasn't actually getting into as a relaxed state as what I thought it was. The IM2 has a number of different meditations. They've got some of the leaders in the meditation world that provide different guided meditations. Some of them are very instructional, and they're actually very beautiful. You can see in the pictures here, they've got lots of beautiful nature scenes involved. So they really are very engaging. So it's a really nice platform, and all the way through, as you go through the meditations, there's lots of different styles. you'll still get your resonance score to really see, did I actually get my physiology into that more restorative state? You'll have this as when you get I'll be sending out the PowerPoint. So there'll be some links, the embedded links here of some research that was conducted, this one by Yale Medicine and one at the Boston Children's Hospital, that you're welcome to look through. And there's some links to some of the demos about the IOM2 as well. And then the other thing I just wanted to add is this, the heartfelt connection, and just expanding this idea of neuroception and our heart rhythm. So the human body produces like complex electrical activity. So all our cells go back down to all the protons. That cellular activity is electrical. All the neuronal activity, or when you do EEG biofeedback, those sensors are reading the electrical activity in our brain. So our body actually creates quite a bit of electrical activity to function. But out of all that, our heart actually produces the most. So our heart's magnetic field, so that SA node, that intrinsic electrical activity that's pumping, that creates the electrical activity for that heart to pump, actually creates quite a larger electromagnetic field, which can extend all around the body. And they can actually use a little special meter to measure that, that electrical field around the body. And you can see that in a picture next to it. So this is some of the research that's coming out of the HeartMath Institute. So Shayla's probably familiar with what I'm talking about. But I know when I first started reading about it, I'm thinking this is like neuroception expanded. That what the HeartMath Institute research they found was that the rhythms of our heart rate, so if we're stressed or if we're calm, gets carried in those magnetic fields, and it can impact those around us. You know how like sometimes you have the expression, oh, I could cut the tension with a knife, or I felt their vibes. That we're actually developing some technology that we can tap into some of these fields that come out from our body. And this is science. This isn't like looking at just like energy fields. This is actually science that can measure different things that come out from our body. And it makes sense from an evolutionary perspective, that, the ability to sense other people's feelings is important in allowing us to communicate effectively, or to pick up if this person's possibly a threat. I was going to do a little, so here, this is some breath work. If you really find this kind of work interesting, there is so much science that talks about the power of breath. I can remember, I think it was earlier in the year, I attended an online seminar on breathing. It was 5 days. And I remember I said to my husband, I said, there's a 5-day seminar on breathing. And we both said, what could they possibly talk about for 5 days? Oh my gosh, it was just like, not that I got to attend all of them. It was absolutely fascinating. So I've really spent more time over this year learning the science of breath, not only how it connects into our heart and into our heart, the heart rate variability, but in particularly our vagus nerve, and exercising our diaphragm, which helps with health with all our digestive system and our posture. That as we sink, as we get older, then our breathing becomes compromised. So we're such integrated systems that we need to sort of tap into the main components of our physiology. So there's a lot of work and research from ancient times about breath work and different breath breathing techniques. So I've just got a couple up there. So one's like a balanced breath. So when you breathe in for 4 and you breathe out for 4. And then an extended is breathing in for 4 and then out for 6. And then working, we really want to try to work on extending the out breath. So trying to slowly breathe out for up to like the count of 8. I'm just putting a couple of examples And then another one is you breathe in for 4, you pause for 2, breathe out for the count of 6 seconds, and then pause for 2. And the whole idea about this is that the science of breathing less, that they really, the science shows that because we're so busy and we're so active, that we're often breathing through our upper chest and we don't even really realizing it. So we're breathing faster. And with that, it actually contributes to our longevity. And that the science of actually breathing less, which means we're drawing out our breaths, creates tapping into this vagal system and tapping into health. So there's a lot of science when we look at breath that we should breathe through our noses. That when we breathe in through our nose, it actually takes the breath from our chest, which is related to sympathetic, down to our abdomen, which is related more to parasympathetic. We actually have more parasympathetic vagal inputs to the lower part of our lungs. So we want to bring the breath down to expand our lower lungs to help tap into this restorative vagus. And our nose breathing, when we breathe in through our nose, if you just try it to, I am last slide, I'll just do it. If you just try now to just get your posture where you're feeling comfortable, your back straight, and breathe in through your nose, just nice for the count of 4. And you automatically feel your abdomen start to expand out, and that's where we want the breath. And then slowly breathe out, and see if you can try and breathe out for the count of 6. And then breathe in, count of 4. 1, 2, 3, 4. And then breathe out slowly through that lower abdomen. So nose breathing automatically, physiologically helps to tap in to bring the breath down to the lower abdomen. Think about those lower libs, parasympathetic vagus. I'm helping to calm, and it's the slow breath. So it's effortless, slow breathing that really helps tap into vagal calming components of our nervous system. And these are things that you help teach your clients as you're about to start the Safe and Sound protocol, or as you're doing the IOM2 or heart math. So we're talking about using those neurotechnologies, the SSP or the IOM2, as ways to tap into our nervous system. I also talked about using how we could use that prosodic inflection of our voice as a way to tap into our nervous system, using our body language to send cues of safety in our facial expression. Breath work is a powerful way to get into our autonomic nervous system, and play and laughter and being creative are ways to help tap into our vagal system. And the more that we can build that into our lifestyle, into our clients' lifestyle, the more that we're tapping into that restorative part of the vagus system. So in terms of using both these tools, really you can conceptualize using them as integrated. You can use one or the other on their own. We're really seeing through the feedback from practitioners, if you can start with a Safe and Sound protocol, it just creates such a shift, as Shayla was saying, in the autonomic nervous system. Then you get so much more momentum from neurofeedback or EMDR or your somatic experiencing or mindfulness or other tools that you think is appropriate for that client. And then if you would like some more additional information, my email's up there, joanne@integralelistening.com.au. Then we also do the training for the Safe and Sound protocol, and to get access to it from here in Australia. We're just launching the digital version. I'm not sure, Shayla, if you've tapped on with that.
I've seen emails.
That's kind of exciting. Mm-hmm.
I'm very excited.
Yeah. So essentially, you just bring, right now you saw in the pictures, it was like MP3 player and headphones. So you sort of use that with your clients, or families or individuals can do this at home with support. And we talk all about that in the training. So obviously, if you would have to ship it back and forth, but with the digital option, it'll be in an app, and you have a dashboard, and you can control who's listening and for how much, and it gives more ways to support clients. And then there's a resource for Dr. Porges, and he's got resources on his website And then I also do a podcast. I've got Deb Dana on there and Stephen Porges and some other presenters. And so, yeah, that's available to listen to as well.